I'm going to show you exactly how to identify 5 valuable crystals hiding in ordinary creek rocks that most people walk right past every single day. You'll learn the specific visual indicators that separate worthless pebbles from genuine treasure, plus the telltale signs professional prospectors use to spot these crystals, even when they're covered in mud and oxidation. Before you start your next creek walk, you need to understand what you're actually looking for, because I can guarantee that 90% of beginners miss valuable finds simply because they don't know these 5 crystals can look completely different in their natural state than they do in jewelry stores. But before we dive in, if you're serious about finding crystals, diamonds, and other precious stones, make sure to subscribe and hit the bell icon, because I share advanced prospecting techniques every week that most hunters never learn. All right, good luck, gem hunters. Foundation section. Here's something most gem hunting guides won't tell you up front. Creek prospecting isn't about stumbling onto glittering crystals that catch the sunlight like something from a fantasy movie. That's the romanticized version you see in documentaries, and it sets up beginners for massive disappointment. The reality? Valuable crystals in creeks are usually encrusted, weathered, and look absolutely nothing like the polished specimens you've seen online. They're embedded in host rock, coated with iron staining, or tumbled so smooth that their crystal structure is barely recognizable. Professional prospectors know this, which is exactly why they succeed, where hobbyists give up after their first weekend. But here's where it gets interesting. This apparent disadvantage is actually your biggest opportunity. While other treasure hunters are searching for Hollywood-perfect crystals and ignoring everything else, you're going to learn what these 5 crystals actually look like in their natural creek environment. This knowledge puts you miles ahead of the competition. Let me set realistic expectations right now. You're not going to find museum-quality specimens on your first trip. You might not even find anything valuable your first 5 trips. Creek prospecting rewards persistence and educated observation. However, and this is crucial, once you train your eye to recognize these specific characteristics, you'll start seeing opportunities everywhere. Creeks that seemed picked clean suddenly reveal their secrets. The 5 crystals we're covering today share something important. They're all found in creek environments across North America. They're all valuable enough to justify your time, and they're all commonly overlooked because they don't match people's expectations. We're talking about garnet, quartz crystals with inclusions, smoky quartz, topaz, and beryl in its various forms. These aren't rare, exotic gemstones that only exist in remote locations. They occur in accessible waterways throughout mountainous and Piedmont regions. The reason most people don't find them isn't scarcity, it's identification failure. Creek environments actually concentrate these crystals through natural processes. Weathering breaks down softer host rock, water transport moves material downstream, and mechanical tumbling in stream beds can expose fresh surfaces. Understanding this geological context transforms random rock picking into strategic prospecting. Think about what happens over thousands of years. A granite formation upstream erodes slowly. Crystals that were locked inside become freed. Lighter materials wash away, while heavier, harder minerals settle in specific zones based on water velocity and stream architecture. This means creek crystals aren't randomly distributed. They follow patterns you can learn to predict. Now, before we dive into specific identification techniques, I need you to adjust your visual expectations. Forget every polished crystal photo you've seen on Instagram. We're looking for rough, often dull-looking stones that reveal their value only when you know the signs. Some will have metallic luster even when wet. Others will show distinctive weight or crystal form. A few will surprise you with unexpected transparency when held to sunlight. The education you're about to receive works in layers. First, we'll cover basic visual identification, what your eyes should search for in the stream bed. Then, we'll progress through location strategy, practical extraction methods, And finally, advanced recognition techniques that separate decent finds from exceptional specimens. By the end, you'll have multiple confirmation methods that work together, giving you confidence in your discoveries. Let's start with the visual characteristics that matter most. Progressive education, Layer 1, Visual Identification. Crystal, number 1, Garnet. First, you have to understand that creek garnets look nothing like jewelry store garnets. In their natural state, they appear as rounded or dodecahedral crystals embedded in metamorphic host rock. The telltale characteristic? A distinct reddish-brown to deep red color combined with a vitreous to resinous luster that persists even when the stone is wet. When you pick up a candidate rock, examine it underwater. Garnets maintain a distinctive shine that quartz and common creek rocks don't exhibit. They feel surprisingly heavy for their size. Specific gravity of 3.5 to 4.3 compared to regular creek gravel at around 2.6. This weight difference becomes obvious once you've handled a few specimens. The most common mistake? Confusing garnets with iron-stained quartz or red jasper. Here's how you tell them apart. Garnets have curved, smooth surfaces even in broken specimens, while jasper shows waxy luster and quartz shows glassy luster with conchoidal fracturing. Garnets also tend to occur as distinct crystal forms, commonly 12-sided dodecahedrons or 24-sided trapezohedrons, even when partially embedded. Crystal number 2, Quartz, crystals with inclusions. Now here's where it gets interesting. Clear quartz is common and essentially worthless. But quartz containing specific inclusions becomes significantly valuable. You're looking for rutilated quartz, golden needle-like inclusions, tourmalinated quartz, black tourmaline crystals inside, or quartz with hematite phantoms. The visual indicator is straightforward. Hold suspect crystals up to sunlight. Valuable included quartz shows distinct internal features that aren't simple cracks or fractures. Rutile creates golden, hair-like needles, often arranged in crossing patterns. Tourmaline appears as sharp, black crystalline needles or fragments. Hematite phantoms show as ghost-like crystal outlines within the quartz structure. Weight alone won't help you here, since it's still quartz. Instead, focus on transparency and inclusion quality. The clearer the host quartz and the more dramatic the inclusions, the more valuable your find. Creek specimens often have one weathered end and one broken end. Examine the broken face for the best view of internal features. Crystal number 3, Smoky quartz. Unlike common milky or clear quartz, smoky quartz exhibits brownish gray to black coloration caused by natural radiation exposure. In creek environments, quality specimens show even color distribution and good transparency when backlit. That's your primary test. Hold it between you and the sun or a bright light source. Authentic smoky quartz transmits light with a distinctive smoky appearance, never completely opaque. The color should be consistent throughout rather than surface staining. If you scratch the surface with a steel knife and the color remains, you've got genuine smoky quartz rather than stained common quartz. The Mohs hardness of 7 means quality steel won't scratch it, but it will easily scratch a penny. The most valuable creek specimens show deep, rich color without heavy fracturing. Look for hexagonal crystal terminations if you're lucky enough to find intact points. More commonly, you'll find tumbled pieces where the smoky color is your primary identification feature. Progressive education, Layer 2, Location strategy. Location strategy separates successful prospectors from people who just hope to get lucky. Let's talk about where these 5 crystals actually concentrate in creek environments. Garnet locations. Garnets originate in metamorphic rocks, specifically schist and gneiss formations. Professional prospectors target creeks that cut through mountain regions with visible metamorphic bedrock. Here's what you do. Find creek sections where the water flows directly over exposed bedrock rather than alluvial deposits. Look for reddish or greenish schist formations along the banks or in the stream bed itself. The concentration zones are where water velocity decreases, inside bends, below small waterfalls, and in natural riffles where heavier materials settle. Garnets, being significantly denser than average creek gravel, drop out of suspension first when water slows. Check any location where you see black sand accumulation, as this indicates a heavy mineral trap. Quartz crystal locations. For included quartz and smoky quartz, you're targeting creeks that drain granitic or pegmatitic regions. Pegmatites are essentially giant crystal formations, where quartz crystals can grow large with various inclusions. Upstream geology matters enormously. Research your area's geological maps to identify granite intrusions and pegmatite dikes. The best creek locations are directly below areas where pegmatite veins intersect the waterway. These zones often show white quartz fragments in abundance. When you find massive quartz debris, slow down and examine everything carefully. Quality crystals break off from these formations and concentrate in the usual heavy spots. But remember, quartz isn't particularly heavy, so it travels further downstream than garnets. Topaz and beryl locations. Now we're getting into the premium finds. Topaz occurs in rhyolite formations and certain granite pegmatites, particularly in areas with historical volcanic activity. Creek topaz often looks like worn, frosted glass pebbles in colors, ranging from clear to blue to champagne. The giveaway: exceptional hardness, Mohs 8, and surprising weight, specific gravity around 3.5 to 3.6. Beryl varieties, including aquamarine and emerald, though emerald is rare, come from pegmatitic and metamorphic environments. In creeks, beryl appears as hexagonal crystals or worn fragments showing a vitreous luster. Colors range from blue-green, aquamarine, to yellow-green, to pink, morganite. The critical visual indicator is the hexagonal cross-section visible on broken or worn crystals. Target creeks in regions known for pegmatite formations. Colorado, Maine, California, North Carolina, and New Hampshire have numerous accessible creeks with beryl potential. For topaz, focus on areas with rhyolite, particularly Utah, Texas Hill Country, and Colorado again. The pattern you're looking for: exposed pegmatite or volcanic rock upstream, with heavy mineral concentration zones downstream. Check inside river bends on the downstream side, areas where tree roots create natural riffles, and any location where bedrock creates natural traps in the stream bottom. Progressive education, Layer 3, Practical Methods. Let me show you exactly how to efficiently prospect these creek locations without wasting hours on worthless material. These practical methods work for all 5 crystal types with slight variations. Equipment and approach. First, you need minimal gear: a small garden trowel or sturdy spoon, a 5-gallon bucket, a classifier screen, 1/4 inch. Hardware cloth works perfectly. A spray bottle filled with water, and a clear plastic container for examining finds. Total investment: less than $20 if you're starting from scratch. Here's the technique that changed everything for me. Don't randomly pick through creek gravel. Instead, identify concentration zones using the principles we discussed. Then, systematically sample those specific areas. Use your trowel to collect material from the top 2 inches of gravel in heavy zones. This is where recent deposits accumulate. Systematic screening process. Pour your collected material into the classifier screen and submerge it in creek water. Shake gently to let fine sand and silt wash through. What remains are stones large enough to potentially be valuable crystals. This immediately eliminates 90% of material from consideration. Now comes the crucial part. Don't examine rocks in a pile. Spread your classified material in a thin layer in your clear plastic container, with just enough water to cover them. This creates optimal viewing conditions. The water reveals luster properties that are invisible when stones are dry, and the thin layer prevents specimens from hiding beneath each other. Identification, sequence. Work through your material systematically using this sequence. First pass. Metallic and vitreous luster check. Garnets and quality beryl show distinctive shine even underwater. Remove anything with that characteristic gemmy appearance and set it aside. This quick visual scan takes 30 seconds and captures most valuable specimens. Second pass, weight test. Pick up remaining candidates. Anything that feels surprisingly heavy for its size goes into a separate pile. This catches garnets you might have missed and identifies topaz candidates. Your brain quickly calibrates to creek gravel weight. Anomalies become obvious. Third pass, transparency test. Take your remaining candidates and hold them to sunlight. Smoky quartz, included quartz, and beryl all show distinctive optical properties when backlit. Common creek rocks appear opaque or show only surface-level transparency. Real crystals transmit light through their structure. Safety and ethics. Critical safety considerations. Always prospect during lower water conditions. Never risk swift currents for rocks. Wear water shoes or boots with good traction because wet creek rocks are treacherous. Tell someone your prospecting location before you go. Regarding legality and ethics. Verify that your chosen creek allows mineral collecting. National parks generally prohibit it. National forests often permit it for personal use with reasonable limitations. State lands vary significantly. Private property absolutely requires permission. The best approach? Research Bureau of Land Management areas and state game lands where recreational prospecting is explicitly allowed. When you find a productive area, practice minimal impact. Don't create large excavations or disturb stream banks. Take only what you can reasonably use or sell. Refill any holes you create. Professional prospectors maintain access to good locations by respecting the environment and property regulations. One final practical note. Weather matters enormously. Recently flooded creeks expose fresh material and may reveal specimens previously buried. Spring runoff and post-storm conditions often provide the best prospecting opportunities. The creek is constantly reworking material. That area you searched last month might yield completely different specimens after significant rainfall. Progressive education, Layer 4, Advanced recognition. Now let's separate decent finds from exceptional specimens. This is where beginners miss opportunities by not recognizing quality indicators. Garnet quality assessment. Not all creek garnets hold equal value. Here's what professional mineral dealers look for. Size obviously matters, but transparency matters more. Hold your garnet candidates to bright light. If light transmits through the crystal, showing that characteristic wine red color, you've found gem-grade material potentially worth cutting and polishing. The shape also indicates quality. Fully formed dodecahedral crystals command premium prices, even in rough form. Partially weathered crystals, showing some intact faces, still have value. Completely tumbled garnets are worth less, unless they're exceptionally transparent and large. Think marble-sized or bigger. Color variations affect value significantly. Deep red almandine garnets are common but attractive. Orange-red spessartine commands higher prices. The rare green demantoid or savorit would be an exceptional find. These show intense green color and adamantine luster. If you find green garnets in creek material, you've hit the jackpot. Quartz inclusions, value indicators. With included quartz, the inclusion type and clarity of the host determine value. Golden rutile creates the most valuable specimens when the needles form dense, well-defined patterns. Random, sparse rutile holds less value. Look for star patterns where rutile needles intersect at specific angles. These are showcase specimens. Tourmalinated quartz increases in value when the tourmaline crystals are well-formed, numerous, and show good contrast against clear quartz. Black tourmaline in smoky quartz has less visual impact and lower value than black tourmaline in crystal clear quartz. Here's something that surprises most people. Included quartz value drops dramatically if the host crystal is heavily fractured or cloudy. Professional lapidaries can't work with fractured material. Your best finds show minimal fracturing, good transparency, and dramatic inclusion displays. Size matters too. Palm-sized specimens with quality inclusions can command serious collector interest. Smoky quartz quality factors. Deep, rich brown smoky quartz exceeds the value of light, whiskey-colored specimens. But there's something even more important: color origin. Natural irradiation creates stable color that won't fade. Heat-treated smoky quartz, relatively rare in nature, may lighten over time. The definitive quality test. Examine for phantoms or internal features. Smoky quartz occasionally contains phantom crystals, ghost-like crystal outlines inside the main crystal. These geological anomalies significantly increase collectability and value. Also, check for scepter formations where the crystal terminated in a shape resembling a scepter or torch. These natural formations are highly prized. Crystal terminations on creek smoky quartz are rare since mechanical action usually damages them. If you find a smoky quartz specimen with intact, undamaged terminations, you've found something special. Even single terminated pieces hold significantly more value than tumbled fragments. Topaz and beryl, premium identification. Wait until you see what happens next when you find these in creeks. Topaz appears deceptively plain, often just cloudy, frosted-looking pebbles. The recognition skill? That exceptional hardness combined with surprising weight. A quality creek topaz feels dense and can scratch quartz easily. Color affects topaz value dramatically. Blue topaz rates highest, followed by golden imperial topaz. Clear topaz is common and less valuable, but still worth collecting. The surfaces of creek topaz often show a characteristic etched or frosted appearance from chemical weathering. This actually helps identification. Beryl in creek form shows that distinctive hexagonal cross-section I mentioned earlier. Quality assessment focuses on color intensity and clarity. Pale beryl has minimal value. Deep blue aquamarine, especially transparent pieces, commands significant prices even in rough form. Green beryl requires expert evaluation. True emerald is incredibly valuable, while pale green beryl has modest worth. Common advanced mistakes. The biggest error experienced prospectors make? Dismissing weathered or stained specimens. Iron staining often obscures valuable crystals. Sometimes, you need to take questionable specimens home and clean them properly with oxalic acid or iron-out solution before their true nature becomes apparent. Another critical mistake: assuming size equals value. A transparent, well-formed thumb-sized garnet significantly exceeds the value of a golf ball-sized opaque garnet with poor color. Focus on quality indicators: transparency, color intensity, crystal form, and lack of fracturing over pure size. Climax and final reveal. Now I'm going to show you exactly how to confirm your finds at home, using simple tests that give you absolute certainty about what you've discovered. This validation system uses multiple confirmation techniques that work together. Home testing methodology. The first confirmation method works for every crystal we've discussed. The hardness test, using a comprehensive scratch sequence. Here's the exact protocol professional mineralogists use, adapted for budget-friendly home application. Assemble these common items: a copper penny, Mohs 3.5, a steel knife or file, Mohs 5.5, a piece of quartz, Mohs 7, and if possible, a carbide scribe or masonry bit, Mohs 9. Cost for everything: under $5 if you need to purchase the carbide tool. Everything else you already own. Detailed hardness testing. Select an inconspicuous spot on your specimen, preferably a weathered surface, rather than a fresh, glassy face. Start with the softest material and progress upward. Try scratching your specimen with the penny using firm, dragging pressure. Most common creek rocks will scratch. Garnets, all quartz varieties, topaz, and beryl will not. If the penny doesn't scratch it, move to the steel knife. Apply significant pressure. You're testing hardness, not just touching the surface. Quartz, Mohs 7, will resist the steel. This immediately confirms you have at least quartz family minerals. Garnets barely resist steel scratching. They're Mohs 6.5 to 7.5 depending on type, so they might show faint scratching under extreme pressure. Here's where it gets really interesting. Use your known quartz specimen to try scratching your unknown. If your unknown scratches the quartz, you potentially have topaz, Mohs 8, or beryl, Mohs 7.5 to 8. If they scratch each other equally, you've confirmed quartz family minerals. If the quartz easily scratches your specimen, it's something softer, unlikely to be valuable in creek environments, but worth investigating further. The carbide test provides ultimate confirmation. Carbide at Mohs 9 will scratch everything we've discussed. If your specimen resists carbide, you need professional evaluation because you've potentially found something extraordinary. Possibly corundum, sapphire/ruby, or diamond, though both are unlikely in typical creek prospecting. Critical hardness testing notes. A scratch test done incorrectly yields false results. You must actually scratch the specimen, not just leave a streak. Wipe away any debris after each test and examine under magnification if possible. A genuine scratch appears as a groove in the surface. A streak looks like residue that wipes away. That's mineral transfer, not scratching. Specific gravity testing, water displacement method. This technique definitively separates garnets and topaz from lookalikes. You need a precise digital scale, available for $15 to $20 online, a cup of water, and thin thread or fishing line. First, weigh your dry specimen. Record that weight precisely. Next, tie thread around the specimen and suspend it fully submerged in water without touching the container's bottom or sides. Record the weight while submerged. The difference between these measurements tells you water displacement. Calculate specific gravity. Divide dry weight by the difference between dry and submerged weight. Garnets yield 3.5 to 4.3. Topaz yields 3.5 to 3.6. Common quartz yields 2.65. This test is absolutely definitive for garnet identification. No common creek rocks share that specific gravity range. Optical property testing. For smoky quartz and included quartz, optical examination under controlled lighting provides clear confirmation. Professional gemologists use expensive equipment, but you can achieve reliable results using a simple LED flashlight and dark room. In complete darkness, press your LED flashlight against the specimen and observe light transmission. Quality smoky quartz shows even, brownish light distribution throughout its structure. Stained quartz shows surface-level color, but transmits clear light through its interior. Included quartz reveals its true nature under this examination. Rudal needles literally glow golden when backlit intensely. Tourmaline crystals cast sharp shadows through the quartz structure. If you see internal features that create consistent patterns, regardless of viewing angle, you've confirmed genuine inclusions rather than surface cracks. Ultraviolet testing, fluorescence check. Here's the part that surprises most people. Some valuable crystals fluoresce under ultraviolet light, while common rocks typically don't. A budget UV flashlight costs $10 to $15 online and provides another confirmation layer. Test your specimens in complete darkness. Some beryls fluoresce faint blue or green under long-wave UV. Certain quartz inclusions may fluoresce. Most creek quartz shows no reaction. This test isn't definitive by itself, but adds supporting evidence when combined with other methods. The most important fluorescence application: identifying certain fraudulent specimens. Glass often fluoresces differently than natural minerals. If something is fluorescing in unexpected ways, it merits additional scrutiny. Advanced home confirmation, crystal structure. For specimens showing crystal faces or terminations, examining crystal geometry provides powerful confirmation. Garnets form dodecahedral or trapezohedra configurations, 12 or 24 distinct faces with specific angular relationships. No common mineral mimics this structure. Quartz crystallizes in hexagonal form, six-sided prisms terminated by six-sided pyramids. Count the sides on any intact crystal faces. Six-sided cross-sections immediately confirm quartz family minerals. This works even on broken fragments showing partial crystal structure. Beryl also shows hexagonal form, but with different proportions, often more elongated than quartz crystals. Topaz forms orthorhombic crystals with characteristic shapes, often wedge-like or columnar, with specific angles that don't match quartz. Comprehensive confirmation checklist. By combining these tests, you achieve certainty about your finds. For suspected garnet, hardness test, resists penny and steel. Specific gravity, 3.5 to 4.3 range. Visual, metallic to resinous luster. Distinctive weight. Crystal form, dodecahedral or trapezohedra if visible. Color intensity and uniformity matter enormously. Pale, washed-out color indicates lower value regardless of transparency. Deep, rich, even coloration signals premium material. Color zoning, areas of different color intensity, reduces value for most gems, but can increase collector interest in specimens. Size considerations vary by crystal type. Palm-sized garnets with good quality are valuable. Inch-sized beryls with excellent color and transparency might be more valuable than much larger pieces of poor quality. Quartz inclusions value based more on inclusion quality than host size, though larger pieces with spectacular inclusions command premium prices. Crystal form completeness significantly impacts collector value. Perfect crystals with undamaged terminations become centerpieces of mineral collections. Creek-tumbled pieces have primarily lapidary value. They'll be cut and polished, so crystal form doesn't matter, except as identification aid.